So hello again, and thank you for your interest in this session about launching our online web-based pantograph-catenary simulation software. And also thank you very much from Jan from KRUCH in Röhl Innovation, and because of his interest in taking a part in this presentation. And he will also present his energy flow simulation software as another simulation tools in terms of pantograph-catenary interaction. So I'm already sharing my screen. You can see the title and things like that. I will go for next slide. A short introduction from our side. Jan is the founder and founder from KRUCH Röhl Innovation. I guess he can introduce himself better than me. And also I'm co-founder and managing director of PANTOhealth GmbH in Berlin. First, Jan will start with his simulation software, energy flow simulation, and then we'll have some Q&A session after his presentation. And then I will go ahead with our software, this dynamic interaction simulation, and then we will have some Q&A as well. So Jan, I think stage is yours. You can go ahead with your presentation. I'm stop sharing my screen and you can share it easily.
Yes, hello everyone. This is Jan Röhl, company KRUCH in Vienna. I will share my screen. So now you should see my presentation. So I shortly introduce myself and the company. KRUCH is a very old company, founded 1869, 150 years old, and we're still a family-owned company, so we can do our own decisions and decide where we go.
One small point, Jan, we can't see your screen. I think you either didn't share it or didn't share the correct.
Yeah, I can't see it either.
Thank you. That's good to know. Now, better?
Perfect. Yeah.
No,
it's
okay.
now I can see it. That's
Yeah,
good.
thank you very much. So again, company KRUCH. Yes, 1869. We are 25 employees, and we are specialized in the design and the production of overhead contact line components. This is what we have done for many decades, and we claim to have a very good position for hanger clamps, tensioning devices, and so on, where we develop our own products and produce them. And out of that knowledge, we have also started to develop software, especially for the energy flow of the overhead contact line. The software development is based in Barcelona and is one of the biggest points that I'm following for the future. We believe that the future is electric, the future of transport, and we want to help public transport to grow success and to be more competitive and to use all resources in the best possible way. And we want to help our customers, the public transport companies, to reduce the life cycle costs and also to reduce energy consumption by at least 20%. And for this reason, we develop our products, which is catenary components and digital solutions, digital dashboards to optimize operations. Like this is our main product for overhead contact lines, our hanger clamp number 2. It's sold all over the world in many countries, as well as for railway operators, as also tram operators and light rail. And that's just a screenshot from our energy flow simulation, where you see in a very graphic way the mathematical results of a very complex simulation. I quickly scroll through overhead contact line products. as they're used all over the world in railways for single messenger, double messenger wires. All our products are adjustable, super easy to install, very time saving, and by this it helps to reduce the life cycle costs a lot. By being adjustable, you can also readjust them at any time. So if over the time position of the tracks has changed for any reason, our products can be readjusted for the smoothest possible run of the pantograph under the contact line. That's something where Farzad will put also some focus on. So we see a big synergy between PANTOhealth inspections and PANTOhealth monitoring systems and our products, helping you to use the results to maintain the contact line in the best possible way. The second big thing is our software solutions, which is dashboards and navigator tools for the different systems of electric transport. And today I want to focus on the most important one, which is the energy flow simulation dashboard. What we do is we will create a digital twin of your network. So we will put in all the contact line, each transformer, every switch that you have, and all the vehicles that you operate, the stations, and so on. And by doing this, we can then calculate and simulate every current on each meter of your network in every second of the day. And when you imagine that you have that kind of power to calculate and simulate in your network, you can do, and this is then offered to you on a web basis, you can do the most complex simulations really easy, very easy to understand. After about 1 hour of showing you how to do it, of teaching you, you will be able to simulate your complete network. And by doing this, you will find what is the electrical limits. So what is the maximum power that your transformers can give? Is the timetable feasible? Can you reduce the minutes between two trains, let's say from 7 minutes to 5 minutes or to 3 minutes? And can your transformer still supply the power? What is an N-1 situation? Is that possible to run? And so on, if one substation is out of service. Now for the battery vehicles, state of charge calculations, in motion charging. What about extra charging points for private transport or for your buses, which are fed by your overhead contact lines? So this is all questions that are out there every day that you will be able to simulate by yourself overnight. And that's the big difference to any other simulation service out there on the market, that you don't have to tender your questions and choose a supplier to answer them and then wait many months, and then you will get many 100 pages of paper with the results. With our simulation tool, you can put in the question in the evening. You just change the settings as you want them, and you press simulate, and after a few hours you have the results. And like this, you will very playfully test what is the limits, how can you improve your network, and you can do that all by yourself. When is substations overloaded? When is the voltage too low on the contact wire? What delays will I get in my timetable by doing that, and so on. All the results are presented in a graphic way, very easy to understand and very easy to apply. So the first step is to create a digital twin. This is an example in Vienna. It's not a real network that we simulate here. It's just to show to customers in presentations. So we have the complete network, the position of the substations, the length of all the cables, the position of the stations where the vehicles are stopping. And we put all that into a digital twin. of the network. After that, we can start simulations, and like here you see in a very simple way, how is the energy balance of a train, how much of the energy is actually consumed for traction, how much is consumed in braking operations, and how much is then fed back into the line. And here you will immediately see what kind of energy optimization potential do you have. And usually we find between 10 and 20% of potential for energy savings with our simulation, and we can help you to harvest that kind of optimization benefits. On the right side, you see an example of different substations and how unequal they are loaded with the power. So the supply of the substations is very unequal, and here you will find possibilities to level out the maximum amps and the maximum kilowatt hours of the different substations and balance through your network. We can also put shortcuts into the system. You can do short circuit calculations. You can see where is the voltage on the line critically low. So just by yourself, you set limits. What do you want to see? Everything below 841 volts in that example. And the simulation will show you where in your network is those areas and in which situation did it occur. And you will see, okay, it was when 3 trams were accelerating in the same second in a certain area, for example. You will get for every tram and every second the profile, where it is in that moment, how it's moving, how the voltage on the line was for this specific tram in that specific point, and with the speed profiles and everything. All that is challenged by measurements. So we compare the simulation to measurements to see how accurate are we. And usually the accuracy is about 10% in one direction. So we have a 10% safety buffer in our simulations. So if the simulation says you are fine, you can do that timetable with that power setting, then it will also work in reality and you don't have to fear any problems. Of course, we can also calculate electromagnetic fields along the line. This is a question that has come up several times in the past when trams are going by, for example, hospitals with magnet resonance and other very fine and very complex, how do you say, analyzation tools, and they don't want to have any magnetic fields in that area. So we can simulate that and then also see how by changed settings you can reduce the electromagnetic fields for that. And just for a moment, I would like to show you how that simulation looks like. So you will get, the only thing you need is internet access, and with any device you can then simulate yourself. So for example, you will have your own dashboard with your simulation tool with the digital twin of your own network. You go on.
Hello.
Yeah. Any question or just continue. So you can create your own simulation. You can give it the name that you like. So you can call it, it's N-1 simulation in winter with heat maximum. And then you can go through, and it's as easy as that. So you decide what kind of catenary system do you have, how much where on the contact wire. Of course, we can change the language any point. Funny thing on the side, most important language is Catalan because our software developers are in Barcelona. So it's always on top of the list here. So you can change the wear of the contact wire to 30%, for example, and you can say it's really cold. So you can say you have minus 30 degrees, and you put the heating on max and so on. So you can really put the harshest conditions in your network and see how the simulation reacts, how your network will react. You can change each vehicle. You can change the timetables yourself. So you can say that you want the trains to go every 3 minutes, for example, because there is a football game or a concert in that area. And like this, you can go through the complete setting and even switch off substations N-1 situation. So I can, for example, switch off substation A to see what will happen if I simulate that. You have graphic pictures of your network at any time to have the overview. And in the end, you press run. And a few hours later, you will have the results, totally graphic and easy to understand. So Farzad, I think that was a very quick overview of what we do. And we see big synergies with our simulation and the PANTOhealth system. And that's why we want to join forces for this and see what we can do together for our customers and what kind of cost synergies we can also have.
Exactly. Thank you very much, Jan. That was, I mean, that was really short for such a big tools which we can use. And for sure, at the end of this session, we'll make some kind of call to action. We'll ask the attendees if our future product, I mean, combination of our monitoring service and your simulation would be interesting for them or not. But before that, let's go to the audience. I think we have time for 1 or 2 questions. If someone has any kind of question from your energy flow simulation, please raise the hand and start the question. Otherwise, we can go ahead with our simulation panel.
Yes, Farzad, Saurabh here. How are you?
Hi, Saurabh.
Yeah, this looks very interesting. I just wanted to know how easy would it be to add models, like build up a model, because every system is obviously different and they have different components. So here in Australia, for example, we have the AT system, the booster transformer system, the 25 kV, and we have various type of DC systems. So I guess I'm imagining that this system is not confined to any particular type of system. So you can actually manipulate it to accept anything in
yes.
As a model.
Yes, correct. So we have most experience within DC systems. So most of our customers are running DC systems. It's tram, light rail, or even subway systems that we have simulated so far. But the simulation is ready for any AC system as well, 15 kV, 25 kV. It's important for you to understand that the modeling part, that's a very complex thing. And that's something that we have to do for you. So we will model your network. We will create the digital twin for you and then offer it to you in our web platform. So then the easy part is the simulation that you can do by yourself. But to build up the model, it's a complex thing.
Fantastic. So Jan, can you also do earthing and bonding study with this package? Like, you know, the effectiveness of earthing, for example.
I didn't understand, could you repeat that? Sorry.
No, just I wanted to know whether the system actually can deal with earthing effectiveness, like simulating earthing system which you have in the network, and look at whether that earthing is capable of, for example, handling a faults or whatever. So there are obviously different earthing requirements for DC and AC. Yep. And those earthing components and methods would be input into this package. Is that correct? So
yes.
then at some point we should be able to look at the effectiveness of earthing systems. So is it, for example, gonna, the number of cables that we have, will it actually handle the fault? Do we need to add anything extra? That sort of thing.
Yeah, we do that. Yes.
I'm imagining that we can do that as well.
Yeah, we do that kind of short circuit simulation. So you can put a short circuit at any point of the network, wherever you want. And then we will see the currents that occur in the transformers and to see if the safety devices are switching off, yes or no. So basically, we put in all cable diameters, cable lengths, and every switch as it is in reality. We put it into the model, and then you can really simulate everything. There has been a lot of questions about stray currents from failed earth contacts. And so that's all within the capabilities of this simulation.
Okay, fantastic. Thank you.
Yeah, it's existing about 10 years already. And we get a lot of customer feedback, what more they want to be simulated. And that's all being developed constantly and growing.
Good.
Thank you.
Thanks.
Perfect. So I will continue, I guess, with the presentation. If you have any further question, you can ask at the end of the session for sure, from both me and Jan. So thank you again, Jan, and also thank you, Sora, for your interesting questions from Austria, I guess. Here, okay. So before presenting the whole simulation panel, I would like to emphasize the importance of doing such simulation in industry or in rail industry. You know, all industries have their own standards, and we also have some kind of standards in terms of pantograph and catenary interaction. So I would like to introduce you just some of these standards, and in which case we have to refer to these standards, who is normally going to that, and for which aim these standards can be used. For example, in terms of pantograph and catenary, we have a quite important standard called EN 50119, which I guess Jan is really into this standard. It's a railway application, fixed installation, electric traction overhead contact line in design and construction or reconstruction phase of the overhead contact line. You need this standard. Normally, OCS contractor like Jan and clients are using this standard to design and also the test of OCS structure and component. But another important standard is EN 50318. The last release was 2018, and it's about the verification of the simulation software for pantograph-catenary interaction. This standard is used in design and validation phase of OCS, and also can be used by OCS designer and client, also train operators and clients. So the aim of this standard is validating the compatibility of OCS and also one operating pantograph. I mean, the output of any simulation software should be validated according to this standard. We have some other standards in terms of pantograph and catenary interaction, pantograph characteristic and test, which can be used in design, manufacturing, or procurement phase of a pantograph. Normally can be used by pantograph manufacturer or OEMs, like their QC departments can use this standard for designing, some kind of design tests, type test, or for main vehicles. We have same standards for LRVs, for light rail vehicles, as another part, part 2 of this standard. And at the end, we have 2 more standards, EN 50317, which is important in testing and validation phase of pantograph and catenary, because they can do some kind of they can check your collecting data process from a measurement pantograph, see if it's okay or not. normally the test centers and clients are into this standard, and so when we become sure that our data collection from measurement pantograph is correct, we can evaluate our collected data to see if the performance of the pantograph and catenary interaction is okay or is according to a standard or not, which has been mentioned in EN 50367. So it's also can be referred by test centers and also some client of overhead catenary system. Also, we have other TSIs, in particular in Europe, for finding any, conflict or problem between different systems in different countries, which can be referred to it as well. So based on mentioned standards, it's important to evaluate or to simulate the interaction of pantograph and catenary. And for this aim, we are developing and using these simulation tools. So what is an analytical simulation tool? I mean, you have some analytical equation in your engineering daily operation, I would say. And in some case, it's super easy to calculate some forces, for example, look like buckling force, as you can see here. You have a direct formula and you can find the buckling value out of this formula. But when the system is getting more complicated, look like the overhead catenary system, and which we do the modeling and simulation in terms of mechanical point of view, and also Jan doing it in terms of electrical point of view. They have the similar equation, but when the number of components are getting more and more, the complexity of the equation is getting more and more, and you have to do it via computers. In order to have a better understanding of the backbone of our equations, which we are using for our simulation tools, I'm going to explain in which method, in which approach we are doing simulation for the whole overhead catenary system. Overhead catenary system has two parallel horizontal wire, the contact wire, which is in contact with pantograph, and the messenger cable, which just carry the weight of the contact wire and keep the form of the contact wire perfectly horizontal. So in both wires will be modeled with a tensile Euler-Bernoulli beam, and the governed equation is already mentioned there. In the left side of the equation is the governed equation on a one element of tensile Euler-Bernoulli beam, and the right side you can see the different force which are applying to this beam, which is the force by pantograph, the force by droppers, and force by registration arm. Rather than this three force, we don't have any other force to the contact wire for sure. We have the same equation for messenger cable, and the external force are, this pantograph is not true for sure here, but it's droppers and stitch wire and supports. Then here pantograph should be replaced by supports. And for the stitch wire, we have the same thing, and the external force are droppers and messenger cable. For modeling the droppers, we are using the columns, simple columns, and we are using a buckling theory to model these droppers. And we also, for registration arm, we are using the stiffness of the registration arm and modeling it as a simple spring. That's also as well as the supports of the messenger cable. The last thing to be modeled is the dropper, is the pantograph, which in this phase we model it as a mass spring damper model or lump mass model, which the value of each mechanical characteristic is defined in some literatures and some reference books. That was about the modeling, but I would like to use the rest of my time to explain the whole software, the whole simulation panel, and how easy you can use this simulation panel as a user. So I would stop my screen sharing to be able to share the whole panel in a browser. So just let me share the screen again. So you can see our main panel here as in a web browser. As Jan said, you only need internet connection to have access to this panel. We have both our monitoring service and simulation service in the same panel. So when you log into the panel, if you are a user of our monitoring service, you can see some potential problematic point in the line as well. At the end of the session, I can come back to this monitoring panel again, but I'm going to speak more about the simulation service, which we can do here for you. Since modeling and simulating catenary is sometimes a time-consuming task to do, you might want to share a project with your colleague to do some kind of share work on just one project. So in your catenary pool, you have different projects, and you can, for example, take one of the project, duplicate it, or you can share each project with any of your colleagues to work on the project together. So, for example, I would like to start with the first example which I have prepared for you. In the first panel, or in the first page of the simulation, you will see this area for modeling and one span of this first section. Then you can go to the second span, third span, and at the end, the last span. You can add more spans if you want for the first section. The good thing is that if you add another span, the geometric of the next span would be same as previous span. So if you have repeatable spans in your line, it would be super easy to do the simulation for that. So the aim is to input the geometric feature of the whole catenary in the panel and see the interaction between pantograph and catenary. You can also add further section here with different overlap. You can change the overlap between two sections if it's 3 span, 2 span, or 1 span overlap. So as that was about the geometric feature, the most important thing, as Jan mentioned in his product introduction, the droppers, the most important thing with contact wire is the horizontal shape of the contact wire. As you can see, normally, yes, if I go to the static result, you see normally the mechanical section of the contact wire would start from with this shape. The new contact wire is coming down with a defined gradient and then go to the line little by little. If I make a full view, it would be easier. So the pantograph is in contact with these sections, go ahead, and new section is coming here. And also the previous section or the old section is going up, super smoothly. So the gradient or the slope of the contact wire is really important in defining the interaction between pantograph and catenary, in particular in the overlap section. So how can we define the gradient of the contact wire? Simply in this model, you can say that, okay, in first span, I would like to start with 5.2 meter as a vertical position of the dropper. Here you can see horizontal position is 25 meter and vertical is 5.2 meter. So you can adjust this little by little, 5.6, 5, and then you can keep the rest as a 5 meter as a vertical position of the contact wire. So each dropper will define the vertical position of the contact wire in its attachment point to the contact wire. But one of the output of this software is the static force of each dropper and also the length of each dropper. So here, for example, you can see the static force of the first dropper is like 200 Newton, 121. And in the third dropper here, we have only 5 Newton static force. It means your designed line is not, really excellent because you have a really low light here. So to increase the dead load of dropper here, you should somehow release this contact wire a bit. And for this aim, I'm just adjusting it to 5 point, for example, 2. And if I do the calculation again, so the new static force for all droppers will be calculated again, and you'll see that, the force will be changed. So the force of each dropper here, and also the length of droppers can be easily, can be easily demonstrated here. That was about the static feature of the all contact wire in each mechanical section. I think I did the adjustment in the first section. So let me change it here. So if I do this adjustment 5.5, just few centimeter, I'm changing the vertical position of the contact wire, and you'll see the result or the effect of this change in the dropper dead load. Here, the dropper dead load is going to be negative, which it means it is impossible to have this curve in your contact wire because droppers cannot carry negative force. So to make it positive, you should raise it a bit. So you would make it like 5 points, for example, 9, just 4 centimeters increasing in the position. And you'll see the results as a dead load or a static force. Here you can see this dropper is positive, but the next dropper is going to be negative. So you have to adjust the slope or the gradient of the contact wire in a way that you will not have any negative dropper force, and neither in the messenger cable nor in the stitch wire. It doesn't matter. So that's about the geometric feature of the contact wire and catenary. And for mechanical properties, for sure, you have to have some kind of inputs: tension per wire, Young models, mass per unit length, cross sections, and things, and also the damping of the contact wire and messenger cable. You have similar properties for droppers, as you can see. You can define it as a rigid dropper, or you can define it as for example, using buckling theory, and there are a lot of adjustment you can do for each dropper. If you change this adjustment, this setting from this part, the setting will be deployed to the whole droppers in the line. But you can also just modify the feature of one dropper from this part. So it's the same modification, but it will be applied only for one dropper. So that was about the definition of the geometric definition of the contact wire, and also the whole catenary. You can see here the static result, and also you can adjust the staggers here. If you make it like 20, it will change smoothly there. So the static result, as I told you, the dead load of the dropper and the length of dropper will be clear. You can see the span view, and also in overlap, you can select each of the span, and you can see the related value to each span, either front span or behind span. And in dynamic modeling, you are able to model the pantograph as a lump mass model. You can change the mechanical properties of the pantograph. You can add further pantograph here and adjust the distance between pantograph, for example, and adjust the speed of the train, for example. And then if you do the calculate and then go to dynamic results, you would see the result of dynamic. But before going to dynamic result, you'll see that for each adjustment, we have some estimated calculation time in seconds, and you can wait like 200 seconds to see the results. But I did the calculation before, and you can see results here.
Can I ask a question?
Yes, for sure. I would rather to have the question at the end of the session, if you don't mind.
Yeah.
Perfect. So I'm just continue like 5 or 10 minutes, and then we can answer your questions. In the results, you can see the full view of the catenary, and then define your, analysis section from, because in the standard, it has been mentioned that the analysis section should be, for example, from section 15 to from span 15 to span 17, for example. So you can select this analysis section as well. And if you apply, you can see the standard deviations, actual maximum force, minimum force would be defined here. And also uplift at each support, you can find, I mean, in each span, you can find the uplift in different supports. Also, the dropper force, you can go for example, each section, you have different dropper force. You can select, I mean, different span. And when the pantograph is passing under one dropper, for sure, it makes a peak, and you can see the oscillation after passing a pantograph. So yeah, it's like that. If you go to a span view, we have make some kind of color code to see how harsh is the situation of each point of the span. And we have 3 different parameters to define the situation: the displacement, the acceleration, and also the velocity. Because when you are simulating the pantograph-catenary interaction, each point of your, I mean, contact wire has a time history. And what you are seeing in this graph is the maximum point of such time history. So it means that in terms of displacement or acceleration, this point has the maximum of this acceleration and in its time history. So you can see also the rest of the contact wire, and at the end, in pantograph moment, you can see all results regarding to pantograph, which the most important one is the contact force. And you can, I mean, overplot 2 contact force to each other. You can also, if you have more than 1 pantograph, you select 2 pantograph, and you can download the video related to the pantograph. I guess if I click on this video, you wouldn't see it. I'm just quickly stop sharing, share the whole screen again, then you would be able to see the video. So that's how the panel is working at the moment. I have some other examples about the panel. I would rather to go to the last example because I didn't expect that the whole explanation takes such time. But yes, if I think I did some kind of examples. So for example, in this example, I did one just simple case study. I changed I mean, in 2 mechanical section, I changed the mass per unit of the contact wire for the second mechanical section. So in the first mechanical section, the mass per unit length is 1.06, which is a normal mass per unit length of a contact wire. But in the second mechanical section, the mass per unit length is like 0.5. It means the half of the contact wire is already weird or already gone. And if you go to the dynamic results, and for the pantograph moment, it was just simple example. For the pantograph moment, if I go to the contact force, you would see the effect of this change in the graph. Pardon. You can see here is almost the overlap. The standard deviation or fluctuation of the contact force before, I mean, the first section is really less than the second section because the mass per unit length of the second section is less. It means when you have, I mean, weird contact wire in your system, the fluctuation of the contact force would be less. As just one example, I did some other examples. For example, changing the mass of 2 different pantograph. Here I modeled 2 pantograph, one with this mass, another with the half of this mass. The results is already here.
I can't see anything on the screen other than just the hourglass, going on and on. So there's nothing actually happening.
Is it the same for everyone?
I can see everything as intended.
So, great.
I can just see your face, but I can't see that. What
okay.
You're talking about. Yeah.
So we will check the records afterwards. If you couldn't find your, I mean, points, we can have a dedicated session sort of after. So I'm open for your questions. And if you have any questions, please let me know. I'm stop sharing and waiting your questions. So who is willing to ask the first question? If not, I can continue just presenting some more use case which I have prepared. But I do prefer to have your questions here.
Yeah, there was a lady that thought, I
Yeah,
thought she
just
wanted to ask a question. I don't know what happened there, but I have a question if she's not ready.
sure, Saurabh.
So,
Go ahead.
yeah, so in terms of dropper distribution, I just have a feeling that in general we use a standard for distribution of droppers, but most certainly the modeling and the assessment that you're doing here is quite interesting, because sometimes we do need to change them to make them slightly better and more effective, I guess. But yeah, so your system would have no problem with auto distributing the droppers without assessment of where is the best place. So we basically have, for each system or different type of systems that we have, they have a dropper distribution, and we just use that distribution. So like every 4 meters, some of them go at the first dropper spacing is 4 meters, and the second one is 5, and then 5, 5, 5. So they vary depending on the span. But there's a table that we use to distribute the droppers.
Definitely.
So I'm just thinking that, is that how you will go about assessment of your droppers using some auto distribution, or do you have to do them individually?
Definitely. Actually, I mean, we have 2 customer categories. The first one is the constructor of the catenary, which are using such standards which you mentioned. For example, if it is like that, they just go and select one of the available standards in the model. And in this available standards, we are using such a pattern which you mentioned, or dropper distribution standard in each design of the catenary. But as another customer segments, if they are like a definer of these standards, for example, someone who is designing the catenary himself in a curve or in an overlap, in a neutral section, and want to try other designs of the catenary or other distributions of the droppers. So in that case, they can modify and change the position of dropper easily. I guess here in this example, I just made this exaggerated positioning of the droppers to see the static results. And if, for example, here, the vertical position of the contact wire has to be like that because of any reason. I mean, it's just one example. If you want to have this vertical position of the contact wire, you should set the length of droppers in this way. Most of these droppers are having negative force, as you can see here, because they have to push the contact wire downward to reach this, profile, this curve. So, so to answer your question, if you are just using one standard shape of the design, so you can select your design and have this distribution. If you want to check the other, possibilities of placing the droppers and setting the curve of the contact wire, you can also try that in this software.
It's good system. And you can deal with solid droppers and flexible droppers?
Definitely. You can make it as a default for all droppers, or you can adjust just one of the droppers, say that, okay, here is solid, rigid dropper, or you can use, buckling theory. The flexibility should be defined. If it is like this flexibility, no zeroing compression, or it has some kind of smoother stiffness or lighter stiffness in compression. So it depends, but all of them can be defined or modeled here.
That's cool. Pretty good.
So
thanks,
to be honest, we started this project almost 2 years ago because we had somehow similar workshop 2 years ago, and we said that we are somehow going to make this product. And after 2 years, we are really happy that we could do it, and we made this product somehow. So I hope that's, I mean, we can find a lot of customers and users for this panel, because you can share all kind of design catenary with your colleague or either even other people in this platform. So if you have any question from my side or from Jan as well.
I have a question.
Yes.
My question is, when the clients need to meet TSIs or European standards, how does your system enable them to not change outside of the scope of, for example, the certification? Does it consider that, or is that fully up to the client? Because if they make changes, they might not meet the requirements anymore in the standards.
I couldn't get your question exactly. I mean, you have your design of the catenary, and the client is going to change or modify this design.
Well, the thing is, if you can actually, okay, so this is for fixed. It's the fixed catenary that this is the system covers. So that's what you're saying. It's not going to affect any standards.
You can
the changes that you do.
Definitely, you can compare the output of this catenary or the output of this simulation with the standard. If I share the screen again, for example, as some outputs of this simulation, you would see the standard deviation of the contact force, which is an important criteria to be compared with the standard. If it is within 30% of the mean value of the contact force, you can say that, okay, this interaction works well. Otherwise, you should make some kind of modification, either in pantograph side or in the catenary side.
Okay, perfect. That was my question. Thank you.
Definitely. You're welcome.
Hello.
Yeah.
Here, actually, like this application is very good. Actually, I think I hope all the flexible systems are shown. Is it applicable for the rigid OCS too?
Yeah, the rigid OCS at the moment is not in our product basket, but the governed equation is almost the same. So we can extend our application to the rigid catenary as well. But at the moment, we are not covering it. Actually, if we come with some kind of dedicated project for rigid catenary, or a serious customer in this term, we will develop our, this use case as well in our platform.
Okay, thank you. Really good to see this software.
I hope so.
So Farzad, is it a demo model of this software?
We are working on it for sure. Today was the product launch, and we were, busy with developing the product itself. Next week, we will be busy with the InnoTrans for sure, but right after InnoTrans, we'll try to, make it some kind of demo accounts for some interested users. We can just let us know if you have any kind of interest, send us an email. We can maybe provide you with some kind of demo account with some limited access, but you can, have your simulation and try some kind of results there.
Okay.
So if you have any more questions, please let me know.
I've got one question. If we had like a simulated section of a real piece of railway that we wanted to put into there, would there be an easy way to upload all that information? If we had it in sort of an Excel or CSV format, would we be able to do a data type upload to it?
Yeah, that's really good question. So far, we are somehow making import from some well-known catenary design softwares like CANDROP, if you know them, from Siemens. But to be honest, it would be so super complicated if we try to, integrate all outputs of different software with our panel. So I guess defining or designing new catenary wouldn't be so complicated if you just duplicate, for example, some sections and change the position of droppers and things like that. So we made the user interface, really easy to resolve this challenge of, inputting the data to it. But if you are using CANDROP, I can tell you that we can do it ourselves. We can input the parameters from the CANDROP automatically. Sure, we can. Can the system model different contact wire tension? Yes, for sure. Actually, in each mechanical section, you can define different contact wire tension. For example, in this example, the second section, the contact wire tension can be changed from, for example, here is 21 kilonewton. You can change it to 30 or whatever. But it's clear that in one mechanical section we cannot have two tension because it's impossible physically. And also, Jan, if you want to add something to your previous presentation, we can have still a couple of minutes. And we can also, there was one question we have presented in our LinkedIn page. I would like to explain a bit about that question. It was about the effect of a stitch wire in the static shape of the whole catenary. If I go with this example, the question was that if the tension of a stitch wire is increasing, or you increase the tension of a stitch wire, the length of the droppers, which are between a stitch wire and these droppers, between a stitch wire and the contact wire, would be increased or would be reduced or would be increased. And the result is it depends, because if you increase the tension of a stitch wire a lot, the messenger cable over the stitch wire would be released, and because of this reason, the length of dropper will be reduced. But there is some optimum value in between.
What I would like to point out is that what you shown before was that when you change the dropper length a few centimeters, or like you explained now, the force in the stitch wire, a few newtons, the force interaction will be affected a lot, or between the pantograph and the contact line.
Definitely.
So what we do here is we design this now in the best possible way. And then the question is, how do you build that? And with traditional overhead contact line products, it's really difficult to adjust the length of the dropper to the exact millimeter. That's super difficult. And that's what we would like to point out, that you need the right products to be able to install that quality that you need.
Definitely. Exactly. That's the point which I would love to mention at the end of the session. The mentioned software, the mentioned platform is not only before constructing, not only useful before constructing the whole catenary, but also after constructing the catenary. And in order to make the contact wires profile smooth and excellent, you need such kind of simulation, or at least a static simulation, because when you see that, for example, the position of contact wire in one dropper is like 2 or 3 centimeter less than its design position, you don't know that how can you reduce the length of the hanger or droppers to put the contact wire on its original position. So first of all, you need some kind of adjustable droppers, which Jan is developing in his, factory, in his company. And second, you need to recalculate the adjustments in the dropper's length. The best adjustment in the dropper length in order to reach your, desired position. So I guess our session was planned for 1 hour, but at the end, if you have any question, if you are interested in the product, we can have time. We have time to discuss more. For me, it's okay to stay like half an hour more for further discussion. Otherwise, we can close. End the session here.
Oh, my name is Michal Satori. And I have a question about the product. It means that we are producer of catenary, and the question is if you are offering the simulation according to TSI, or you could sell the product and the simulation are on our side. What is your position in this approval process?
Yeah, actually, it's all self-service product at the moment. You can do the simulation yourself. We just give you an access to the whole panel. You can do the simulation. You can change the mechanical properties. You can change the geometric properties. Whatever you want, you can just redo the simulation and see the effect of any change in the results. That's our position. And we want to just sell the account, the access to this platform.
Okay, and second question is about the pantograph model. Could we choose the pantograph specific one, or there is one pantograph? Because this model is somehow connected to some type of pantograph. Could you describe the type?
Yeah, definitely. Actually, there are some handbooks and reference which have these parameters for different type of pantographs, some articles. You can use them. We have also them. We can consult you to use them. There's another option to load the dynamic response of the pantograph. So you can put the pantograph, if you are the manufacturer of pantograph, for example, you can put the pantograph in a vibration test laboratory and see the dynamic or frequency response of the pantograph and put it here. So we can model the pantograph based on that dynamic response. But you can even change the mechanical properties of the pantograph. Normally, you can find them in the articles, and we can consult you regarding that point.
Thank you. Thank you for answers.
Welcome.
Maybe once again, a question about the speed. You could simulate, or is this model somehow limited with the speed of train, or it's, I don't know.
No, the limitation is not coming from this from the model. You can add, for example, 800 meters per second, kilometer per hour. But according to the standard, the result of simulation is only valid, I guess, up to 20% of the speeds which the standards are. For example, here in this case of the standard. So if you want to be within the acceptable range of the standard, and you want to use your results as a validation for pantograph-catenary interaction, you should take care about the validation range of the standard. Otherwise, you can do your research in whatever speed you want.
Thank you.
So just one point which I would love to add here. If you want to check the validation of the software with the standard, as I told you, there's one dedicated standard, EN5318. And in this standard, there are 4 different models. 2 is the reference model and 2 is a field test. And you should put these models in your simulation software and see the results. And if the results is within the acceptable range of the standard, you can claim that, okay, based on the standard, our simulation software is validated and you can trust the result of the simulation software. So to make it also crystal clear and transparent to our customers, we are putting this standards model as a one project here in your catenary pool. You can select this project and do all calculations, both static and dynamic calculation, and you can check if, I mean, the whole results is within the standard anytime you need. So the validation of the software is also self-service. So we don't have any certificate to say that, okay, for example, this laboratory has certified it. You can do the validation for your clients whenever you want.
Okay, thank you, Farzad. That was really good.
You're welcome, Saurabh, and I hope everyone enjoys this session. If there's no more question, we can end the session.
I would have one last question, maybe.
Sure.
Is there, I mean, I'm new to this and it looks really excellent. Is there also, from a commercial point of view, something, a calculation or a storyline, what we can save with that for the customer, or the user can save for himself if he uses that, or avoid cost?
Yeah, exactly. Actually, it's look like engineering software. So it's not B2C software, which the customer can feel, I mean, the direct benefits out of this software. But the point is that the application of this software is first design of the catenary. If you are going to follow the standard design of Siemens, ZCAT, blah, blah, you might want to check this design with your current available pantographs in the line and see if this design is compatible with the pantograph or not. If not, you can change your design as a, I mean, client or as a constructor of the catenary. Another benefit of this software is like modification in, for example, neutral section or in curves or some points which you have, I mean, unexpected wear rate in the contact wire. You can check the reason of this wear rate, and you can modify the line by changing the position of the droppers or changing the height of the contact wire a bit, adjusting it a bit, and avoid such a, I mean, high or intensive wear rate in your contact wire. So it would be another application also for companies who are manufacturing the overhead components. They can check the, for example, dampings and stiffness and other mechanical properties of each component before going for new product. And that's all something which the customers can use it directly, but from our side, we have another product, our monitoring service. If you see my screen, I can share it to you. So we are also providing some hardware and sensors to be installed on the pantograph, collect data from pantograph and catenary, and tell our customers where is the problematic point and which kind of reaction you should do with this problematic point. If you need to modify the contact wire, the catenary, if you need to change something in the pantograph. So in this case, we for this aim, we are, I mean, somehow changing. We are combining the data coming from the simulations and from the real-time monitoring to find out the reason behind each problem. So some benefit of this platform goes to our AI engine to find out the reason behind any problem.
Further, I suppose it could be used quite a lot in positioning section insulators because there's point loads in the system, and they will require special type of droppers and special spacing of droppers around that section insulator. So I suppose that would be one area that I can see a good advantage, a good benefit from this.
Yeah, thank you for mentioning that. Definitely. I mean, the weight of the section insulator, the droppers which are holding or handling the section insulator is also should be designed, and this software can simulate this design as well.
That's right, because we usually hog the section insulator a little bit, because as the pan pressure comes to the section insulator to make it all nice and smooth. So that hogging of section insulator sometimes is quite critical, and you have to know exactly how much to hog the section insulator to get a smooth run with a pantograph.
Yeah, definitely. So if there is no further question, or also Jan, if you want to add something, if no, we can end the session right now. Great. Thank you very much for your attention. And also thank you, Jan.
Thanks
Thank you very much.
Thank you very much.
Thank you.
Thank you.
Thank you
Bye.
for a very
Bye.
interesting talk.
Have a nice day. Thank you.
Bye.
Bye.